Move. Abedimpo. Kwame Kofi Kinata.
Welcome to today's lesson. This lesson is part of the course for the 5 semester program from UCC. As you are aware, this course is titled Analytical Chemistry. The course code CHE 301SW. This is the first lesson for this course. The title of the lesson for today would be about language of analytical chemistry. I'll be your facilitator for today's lesson, and my name is Andrews Ajiman, also known as Teacher Kwame. In today's lesson, we'll be looking at the general overview of analytical chemistry. We'll also be going through the purpose of the lesson. As the title of the lesson suggested, we'll be dealing with language involved or some of the terms involved when dealing with analytical chemistry. So we'll be looking at some of the keywords. Here we're looking at analysis, analyte, determination, and measurement. Other words would be techniques, methods, procedure, and protocol. We'd also go to look at classification of some analytical techniques and how we can arrive at selecting a good analytical method. The last but not least would be to look at calibration and then standardization. Are they similar or there's a difference? If there is a difference, what differentiates between the two? So stay tuned as we go through the lesson with you. As you are aware, in every part of the world, i.e. the society, is governed by special language spoken by the various people living in these particular areas. Some of the words or the languages that are being used, we find their meaning being similar to other words used elsewhere. Others could also differ. Just like those aspects of the language, analytical chemistry has its own special language. And this language is to help for effective communication and understanding. So, what then is an analytical chemistry? In general, we are saying that analytical chemistry serves as the backbone of all scientific investigations. It makes provision for the essential tools that would help us in identifying, quantifying, and also the characterization of some chemical substance of interest. Talking about analytical chemistry here is talking about how many techniques or terminologies that are very essential. Now, we are saying that once language is able to help us to communicate, having one common term or terminology or language in the circles of analytical chemistry would help us to communicate amongst ourselves as analytical chemist in order to enhance communication and better understanding. So, in this lesson, we are going to be looking at some of the key terms that is being used in analytical chemistry that has already been laid down so that all chemists will have a common language to help coordinate all the things that are being done in this aspect of chemistry. This is done in order to have a solid foundation for future studies. Now let us look at an overview of what analytical chemistry is. We are saying that when we study theories and its practices in terms of the methods that are being used to determine the composition of matter, such study falls under a special branch of chemistry. We are calling this branch as an analytical chemistry. Again, analytical chemistry can be defined as the study of the separation, identification, and quantification of those chemical components that are of interest, being it natural or artificial. From an analytical perspective, in order to have any solution to a problem, you have to go about identifying and then defining the problem at hand. Once you are able to identify the problem, you can then set out to design an experiment. Once you have confirmed the kind of experiment that you want to do in order to solve the problem, you have to conduct an experiment. Conducting an experiment would aid you in gathering data about the said problem. Once you have the data at hand, you have to look at the data and let it speak to you. In this way, we are saying that we are giving meaning to the data. We are analyzing the data. Once the data has been analyzed and meaning has been gotten out of it, we can then propose a solution to the problem that we have identified in the first instance. From number 1 to number 5, that is identification, to proposing a solution, is what we are saying to be the analytical perspective. Now, let us look at some of the terms in analytical chemistry. The first of the languages or the terms that we'll be looking at is analysis. Analysis. The word analysis in analytical chemistry here has to do with finding out information. It has to do with whether it is the chemical or the physical aspect about a sample of interest. For example, you'd have a piece of mango on the table. Now you want to find out whether this said mango is ripe or not. Looking out for information about the said mango, whether it is ripe or unripe, whether you want to divide it into special pieces, grind it or not. Those bits of information that you are getting by looking and then turning the mango is what we are saying to be analysis. So, in definition, we would say that analysis is the process of determining or finding out about the physical and chemical properties of any given matter. Now, analysis can be categorized as whether you just want to identify any matter, and you're only identifying it, whether it is by color, by shape. We categorize this as doing qualitative analysis. If you want to know the specific amount, it means that you want to quantify it. And here we are saying you are conducting a quantitative analysis. So chemical analysis are grouped into qualitative analysis and quantitative analysis. When you are analyzing any matter, you are going to employ various techniques or methodologies. And you do so in order to obtain accurate and precise results. Because as an analyst, you want to make sure that whatever information that you are getting whilst looking at the various aspects of a sample should be the correct one. Chemists, in terms of analytical chemists, do not want to make series of errors. That's the information that they would provide, the key to various findings. The next language or term is analyte. Analyte. Remember that we have already looked at analysis. Here we are dealing with analyte. We have said that analytical chemistry has to do with looking for information about any given matter. And by so doing, you are going to employ various techniques and methods. Now, that special matter or that given matter that we need specific information about, that is whatever we are looking for, or whatever is our target, or whatever component that we are seeking to know is our analyte. That is, the item or component is what is interest to us. For example, you can go to a car showroom with various brands of cars. But what the car that you are interested in buying would be a Toyota brand. So now, at the showroom, the specific car that you'll be looking out for would be a Toyota branded car. That car becomes your target. In analytical chemistry terms, it will be your analyte because that car is of interest to you. Now, the word analyte in clinical chemistry terms can be said to be a component. In titration, it is mostly referred to as the titrant. So in a nutshell, any chemical species of which is of interest to us, that is, their properties, whether physical or chemistry, whether physical or chemical, sorry, that we are trying to measure in any experiment is our analyte. Any chemical species whose property, whether it is chemical or physical, of which we are trying to identify or measure in an experiment form, is our analyte. The next term that we are going to look at is determination, to determine. Now, in analytical chemistry, when we say to determine or determination, here we are looking at all processes of measuring and then quantifying the amount of the concentration of the species that we are interested in a sample. When we apply various techniques, methods, and instruments in order to determine that specific amount of the chemical species, which is the analyte that we want. When we say we are determining something, here we mean to say that having identified that species of interest, we would be comparing the properties, whether it is chemical or whether it is physical, or if it's a response that is being given to another, which is termed as the standard or the known standard. If it is in the graph form, we are looking at the calibration curve. So, in analytical chemistry, we determine by measuring and quantifying the concentration of an analyte. Measurement. When we measure, we are saying that we are trying to obtain some bits of information about the properties of a substance. This kind of information can be quantitative or qualitative. Now, to measure here, we'll be dealing with determining various parameters such as the volume, temperature, or any other important properties of the analyte. Now, measuring in analytical chemistry would involve some key steps. Some of them can be listed as sampling, calibration, the measurement itself, and so on. I've provided various explanations to some of these key steps in the handout that will be provided in addition to this video. Now let us consider this scenario in order to connect the terms that we have done so far. We assume that we have a box full of mangoes. Some of them are ripe, others are unripe. Our main goal is to select and count the number of the ripe ones that are in the box. Our goal is to look at which ones are ripe in order for us to consume it. Even though we are looking at eating the ripe ones, we want to know the exact number of the ripe mangoes that are in there. On the selection of these ripe mangoes, we want to be looking at how strong some are, how big some are, how heavy others are. Looking out for physical information. How then do we situate the language that we have dealt with so far to this? I.e., analysis, analyze, determination, and then measurement. What we have here is a box that is representing the box, comprising these yellow colored balls and then the green colored balls. Once we consider these colors in the box, we are saying that all of them together becomes our sample. Becomes our sample. The process in which we will go through in the selection of the mangoes, that is the ripe one from the unripe ones, is what we termed as analysis. We are performing an analysis. Now, what is the mango of interest? The mango of interest here is the ones that are ripe. The ripe mango then becomes our analyte because that is the one that we are interested in. Now, once we are able to take out the ripe mangoes from the box, whatever is left in the box becomes our matrix. Say the word again, matrix. M-A-T-R-I-X. Now, after we have been able to select the ripe mangoes from the ripe ones, we are saying that once we go through identification of the ripe ones, measuring them whether they are big, small, or heavy, and then being able to quantify them, we are saying that we are determining it. Hence, we are doing determination. Now, once we determine the size, the weight, or how heavy it is, based on some parameters, then we say that we are measuring it, hence undergoing measurement. Undergoing measurement. So you see, we have looked at what we mean by analyte, something that is of interest to us. If you take out the species of interest, whatever is left is the matrix. Once we are able to identify, measure, and quantify the analyte, it means that we have been able to determine it. Once we are doing the determination here in terms of specific parameters, then we say that we are measuring the species of interest. We are measuring the analyte and undergoing measurement. This is a flowchart form to help you better understand what we have done so far. Study it carefully and connect it to what we have talked about the past few minutes. Once you are done, we can move on to the next set of terms or language. All right, now let's move on. Here is a summary of the core points for the first part or the first set of terms. We are saying that in an analysis, we determine the identity, concentration, or properties of an analyte. Remember, we have said that the analyte is that of interest to us. In order to determine this, we have to measure. What are we measuring? We are measuring the analyte's chemical or physical property. Once you have a sample and then you take out the component of interest, the remainder of the sample becomes our matrix. So we have a sample. The sample contains an analyte. We take out the analyte. What is there or what is left is our matrix. Now, in an analysis, to identify the property, we have to determine. And to make this determination, we have to measure. This sums up our core point for the first part of this lesson. Let us look at the new set of terms or language. The first one that we are going to look at in this section is technique. Technique. In short, we are saying that techniques are principles. It can be chemical, it can be physical. And these principles are employed in order to study any object of interest. For example, what principle would guide us if we are to select ripe mangoes from the unripe ones? What chemical principle or what physical principle would serve as a guide? Examples have been given at gas chromatography, voltammetry, etc. An analytical technique would be developed based on two things. One, a technique would be developed based on their precipitation reaction, or two, based on the chemical reaction of the sample. So let's look at this flow chart. If it is based on precipitation reaction, we are naming it as gravimetry. Gravimetry. If it is based on chemical reaction, we are looking at volumetry. Volumetry. We have explained this in detail in the attached notes to this slide. Now, when we apply principles in order to study and analyze, that application of the said principles or application of techniques is termed as a method. Hence, when we talk about a method, we are looking at how well we apply principles, how well we apply techniques in order to, for example, identify, characterize, and quantify any analytes. Now, these applied techniques, we are saying outlines the step-by-step instructions whenever we are preparing a sample or we want to calibrate an instrument. So in other words, they are providing standard approach. And why do we need it to be standard? We need to be consistent so that whatever results that we are producing can be reproducible in the analytical process. Examples like standard addition method, gravimetric method are all step-by-step instructions. Step-by-step instructions. In all of this, we are saying that we are applying principles. Hence, we are applying techniques. Once we apply that, it means that we are doing a method or using a certain method. Now, methods can be categorized into two. We can categorize methods into classical or instrumental methods. Now, in classical method, or what we mostly call wet chemistry method, the separation mode is by extraction, distillation, or precipitation. Whilst for the instrumental method, we are looking at examples like chromatography. Now, in the classical method, measurement of physical quantities, if it is in the quantitative form, is separated by determining its weight or volume. In terms of the qualitative, we are looking at odor, color, or melting point. For instrumental method, we are looking at light absorption, or even how well it's able to conduct in its conductivity. Conductivity. Now let's look at the individual categories. When we look at instrumental methods, we are saying that there can be three methods under it: electroanalytical, suppression, and then optical. Now, under electroanalytical method, there is measurement of volts or current in a cell. Keyword here is electro. Say it again, electro. Example of such methods we are looking at potentiometry, conductometry, voltammetry. In the suppression method, we are saying that it depends on the component. For example, if you want to distill liquid, what property of the component are you going to be interested in? Filtration of a given sample. What properties are you going to be interested in? It is based on these properties that separation can be done. For example, solid liquid mixture. If you want to filter it, the ability of one to penetrate through the filter paper. Optical method. Here, we are looking at how well your sample would react with electromagnetic radiation. Once radiation is mentioned, a rough idea has to do with light. That's what you would think. Microscopy, spectroscopy, and so on. For the classical method, like we've already said, it's either quantitative or qualitative. We can have weight and the volume. We are looking at some analysis like gravimetric analysis or volumetric analysis. Now let's have a look at this term, procedure. Procedure. We are saying procedure is any set of written directions or given directions that is telling us how we can put the method to use in order to help identify and analyze in a given sample. So once we know that procedures are written directions, the method in itself could have so many written directions. Hence, the method can have so many procedures, of which as an analyst, you would want to adapt in order to find your analyte that is of interest to you. To give it a general definition, we can say that a procedure is a set of systematic and predefined steps that as an analyst you need to follow. Now we are doing this, that is following these set of systematic and predefined steps in order to perform a specific task. Procedures are set to outline detailed methodology, or you can say methodology. I hope you get the difference now. We talked about technique, methods, procedure. Now let us look at another term, protocol. Protocol. We are saying that a protocol refers to set of guidelines or instructions that is telling us about specific procedures that has to be followed in order to perform a certain experiment. What is entailed in this protocol? We are saying that protocol gives us detailed information about even how to prepare samples, what kind of instrument that we need to use, how we can calibrate this said instrument, what kind of measurement technique to use. Once you have your data, how do you analyze this kind of data? The protocol then becomes a guideline or instructions. Now, these instructions are supposed to help us to ensure accuracy, precision, and then be able to compare results with standards or others. Later on in the lesson, we'll be looking at what we mean by accuracy and precision. Now, let us recap what we have done so far in this second section. We are saying that techniques are approaches or principles that are used to perform measurements. Now, when we talk about method, we are looking at the overall approach of conducting an analysis. And this would include combining several techniques. Procedures are said to be step-by-step instructions, and a protocol refers to well-documented sets of guidelines. Inside the protocol, you'd have your procedure, techniques, and methods to be followed. In short, we are saying that techniques are tools. Method can be referred to as strategies. Procedures will talk about a detailed step by step, and protocols are documented guidelines. Study this flowchart in order to differentiate among the various terms we have done in the second section. In the next section, we'll be looking at classification of analytical techniques. Classification of analytical techniques. Now let's look at classification of analytical techniques. Now let us consider this. When we analyze a sample, we assume that the sample would generate a signal, and such signal could be chemical or physical. For the purpose of mathematical equations, let us represent signal by S. Now, in any given sample, the physical or chemical signal that is given by the analyte is proportional to the amount of analyte in the sample. In other words, if you have a high signal, it's expected that the amount of analyte in the sample should be, quote, plenty or many or a sizable amount. Now, we are saying that these physical or chemical signals are the ones that are going to be measured. For example, in a mass spectrometer, it is the abundance or the mass of these signals that would be measured. Techniques are therefore divided into two classes. Now we are saying that if we are dividing these techniques into two, it is done based on whether the signal is proportional to the mass or the number of moles of the analyte, or is proportional to the concentration of the analyte. Now, if your sample is being classified based on the fact that the signal is proportional to the mass or the moles, here we are saying that you are going to use total analysis technique. But if the signal is proportional to the concentration of your analyte, you have concentration technique. So in simple mathematical expression, S is proportional to mass or moles. Now, if we want to do away with the proportional sign, it means we'd have to introduce a constant, and in this case, K. So the equation then becomes S is equal to Kn, which is the N representing number of moles, or S is equal to Km, where M is mass. For the concentration technique, S is equal to Kc, that is equation 2. Now let us look at this flow chart to help us give a general understanding of the difference between the total analysis technique and the concentration technique. We start off with a sample analysis. Now we are saying that when we are analyzing a sample, that sample is supposed to give us a signal, and that signal could be chemical or physical. We are saying that the signal is going to be proportional to whether you have mass or the number of moles. And when it is mass or number of moles, That technique is referred to as the total analysis technique. Now, example of such techniques could be gravimetry, titrimetry. Gravimetry would have to do with the mass, titrimetry number of moles. On the other hand, when your signal is proportional to the concentration, then we are looking at the concentration technique. One thing you should note is that the K in this equation is determined experimentally. Never forget that. Some of the examples of these techniques under concentration technique, we have spectroscopy and electrochemistry. Now, how then do we select an analytical method that is suitable or it's good to determine an analyte? And here we are saying that the first thing that is of importance when choosing or selecting an analytical method is the requirement of the analysis. What is the kind of requirement that the analysis seeks? And let's look at this scenario. You're going to fetch a cup of water from your tap. Now you want to determine whatever analyte is in the, let's say, lid. Using three methods. And the methods here are gravimetric, titrimetric, and then electrochemical. Now, each of these methods would be chosen to determine the lead residue based on what the analysis wants. For example, if we are looking at gravimetric method, then we are interested in the mass of the lead that is contained in the cup of drinking water. Hence, how what is going to be measured. For the trimetric method, we'll be looking at how the lead is able to form complex compound. And with that, we would use the AAS. Now, if the lead exists in the various forms of oxidation states, then it means that we will have to make use of the electrochemical method. So now, you realize that all the three methods that were chosen were based on what is required from the analysis or by way of the analysis to be done. The first part, precipitation is key. The second trimetric one, compensation is key. The last one, the various oxidation states in which the lead would exist. Having said that, we are saying that when it comes to a matter of choosing a method, some things are considered. Things like accuracy, precision, ruggedness, analysis time, availability of the said equipment, and then the cost. Now let us quickly look at the meaning of the criteria that can be used to select a method. The first is accuracy. When we talk about accuracy, we are saying that when you perform any experiment, the results that is obtained from these experiments, how close is it to the expected results or the true value that we are measuring? Precision. When we say something is precise, what we mean is that how close is the measurement of the same item to each other. For example, we want to measure the weight of a red pen. We make several measurements. The values after each round of measurement, how are they close to each other? If in terms of the results or from the measurement, the values are closely related to each other, then we can say that it is precise. So, the key things that we can take from precision is that the sample is analyzed several times, and that we expect that once the sample is analyzed several times, the values that are gotten are very close to each other, and we say that the results are precise. Sensitivity. When we talk about sensitivity, we are looking at how the difference between measurements can be established. In other words, in an analysis, the ability to demonstrate that two samples have different amounts of the analyte is very, very key. Let me go over the sensitivity again. Going over the sensitivity again, we can say that sensitivity would represent the smallest amount of substance in a sample that can be accurately measured. Whilst selectivity, which is the next one, is the ability to be able to measure something without any interference. Or we can say that This method would be able to be free from any interference from other components in the matrix. For example, if the analyte of interest is in a matrix, that method should be able to detect the analyte without having to worry about interference from other components. I hope you get the difference between sensitivity and selectivity. Very good. Now let us move on. Now let us look at the meaning of the R's, robustness and ruggedness. Robustness is the ability for a method to be able to resist interference in such a way that it can be used to determine many sample of interest or many analytes in a range of sample. Whilst ruggedness is when a method has the ability to resist changes in conditions of the experiment. We are saying that for robustness, we are looking at when a method is relatively free from interference. And with that, it can be used to determine many analytes in a wide range of metrics. Now, let us look at the last part of the lesson, where we'll be looking at calibration and standardization. In terms of calibration, we are saying that it comprises of all processes that we do in order to establish a relationship between the responses of instrument and then the concentration or quantity of a known substance. Now, what happens is that series of measurements are done with materials whose concentration or quantity are known. And these materials are referred to as standard reference materials. Once these series of measurements are done, a calibration curve is then plotted, so to speak. So in case we want to find out about any unknown sample, do the measurement and then determine the concentration using the calibration curve. Let us simplify this understanding. Consider yourself in the market where you are going to buy a piece of meat. You go there and then you realize that the man behind the shop asks you of the amount that you want to buy. So you, in reference, you tell the person that, oh, I want to buy 20 pounds. So then how sure are we that the weighing scale that the attendant is using is indeed going to give us our 20 pounds? We can only say that indeed whatever the man is measuring or weighing is 20 pounds after we are sure that the man's instrument has been calibrated. Calibrated in the sense that the weighing scale has been used to measure series of standard weights where the instrument has been checked to weigh exactly the amount of the standard that is available, whether it is 20 gram or 50 gram and the rest. Then when you are buying a certain amount of the meat, you know that whatever meat that the man is giving you is at least close to the weight that you are looking for. And here we are saying that calibration is essential for accurate and reliable quantitative analysis because it's going to account for these systematic errors and then deviations in the instrument or method that we are using. We are all doing this in order to ensure accuracy and precision when we use our methods or instruments to measure our samples. Now let us look at standardization. Here we are saying that standardization is the process of determining the exact concentration of a substance. Now how do we determine this exact concentration? This is done by comparing it with known reference materials or known standard materials. Once we are doing some form of comparison, it means that we are trying to establish a relationship between the measurement signal that is coming from the instrument and then the property of the analyte that we are interested in. Let's look at this example. We assume that we are in an analytical lab and that we want to determine the concentration of a specific analyte in a sample. And in this example, we want to determine the concentration of lead in a water sample. We can use certified reference material that has the concentration known in terms of the lead as our standard. Now, when we analyze this certified reference material, and then we compare it with the signal that is coming from the instrument to the known concentration of the lead, then we can establish what we call an equation or a calibration curve, where we relate the instrument responses to the concentration of the lead in the water sample. The use of the calibration curve is to help us determine the concentration of the lead in the unknown water sample. And that is done by measuring the response from the instrument and then applying it in the calibration equation. The reason why we are using certified reference materials in this example is to ensure accuracy of the measurement of the lead concentration in the water sample. Now let us readily look at comparing calibration and then standardization. For calibration, we are saying that we are establishing a relationship between responses from the instrument and then the concentration of the analyte. We are also ensuring accurate measurement by also correcting the instrument or any procedures for any variations that will bring about systematic error. On the other hand, standardization involves the use of a reference material to establish a known value for a particular property or analyte. In all, calibration ensures accuracy. Standardization also ensures accuracy. Here, we are also comparing the responses of the instruments. Responses of the instruments. We are also comparing the responses of the instruments. I hope it's clear. If you have any other clarifications that you want, please write them down, and then during the discussion stage, we'll address all of them. Thank you for joining our class, and we'll be waiting for you in the discussion room. Thank you.